Good afternoon. I am going to work through 2014 National 5 Paper 2. This is a calculator paper, so make sure you have your calculator ready. Remember, try the questions, pause the video as you go through, take notes, and if you need help, just let me know. I will be on. Available Friday afternoon, Friday the 15th. That's normally when we have the double period of maths in the afternoon. Okay. Okay, number one, 964 pupils on the roll. It's forecast that this number will decrease by 15% per year. What's the expected roll after 3 years? Okay, so have your calculator ready, please. If this was an increase by 15%, we would be looking to multiply by 1.15, okay? You increase by multiplying by 1 point something. We're actually decreasing by 15%, so we don't multiply by 1 point something because that increases. We multiply by 0 point something to decrease. So what we're doing here is 964, we're going to multiply by 0 point something to decrease. We're basically taking off the 15% off 100%, so we're multiplying by 0.85. Okay, if it was decreased by 5%, it'd be 0.95. And because it's 3 years, we do this to the power 3. Okay, remember, if there's any other question that you would have done slightly different, just take your calculator, work it out, and see if you get the same answer. Because quite often there can be a couple of different ways of doing the same question. So what I've got here is 5, and please do check this yourself. Okay, I've got 592.015, always read the question at the end again. Give your answer to nearest 10. If you don't do that, you're only going to get 2 marks worth, okay? Give your answer to the nearest 10. This is 592, 590. Okay? Okay, number 2, let's see, coordinates, 3D coordinates, x, y and z. So we've got 3 different components here, 3 numbers, x, y and z. X is your number across the way. Every coordinate has 3 values. X is your first number. The y value, you'll notice, is here, which is the number in that direction. And the z is the number up the way. Okay, so the question says A is 864, right? Where's point A? Right, there's A. What that means is it's 8 along the way to get to point A, and then it's 4 back. That's what the 846 means, it's 4 back the way. And then point A means it's 6 up the way. That's where the 846 comes from. Right, okay, it says this is a cube on top of a cuboid. So this here is a cube. Now, what do we know about a cube? A cube has length, breadth, height, all the same measurements, okay? Do we know any of the measurements? Yes, we do. We know that wee distance there. That wee distance is 4. So if that's 4, every measurement of the cube is also 4. So that's 4 along the way, and it's 4 high. So the question is, what are the coordinates of B and C? There's B up there, okay? How many along is B? B is 8 along. It's still 8 along, same as point A. How far back is point B? It's still 4 back. It's in line with point A. But how high up is point B? Point A is only 6 up, but remember, this is another 4 up. So 6 and 4, it's 10. Okay, total of 6 and 4 is 10 high. We're also looking for point C. Your 3 values for point C. Where is C? Right, there's C over here. Right, across the way first. It's 8 across. No, it's not. It's 8 across to get to point A. But to get to point C, it's 4 back the way. So this distance is actually only 4. Point C is 4 along. How far back is point C? Any distance in the y-axis in this y? No, it's not. Right, it's in line, so it's actually nothing back the way. We're just going straight up to point C, and the height of point C is exactly the same as the height of point B, which is 10 up. Okay, you're 6 up plus your extra 4. Okay. Next one, 2 groups of people go to theatre. Bill buys a ticket, 5 adults, 3 children. I hope you can see what or you should be able to identify what type of question this is. This is a simultaneous equation question. Write an equation to illustrate the information. Right, 5 adults and 3 children, and the total price is this amount. Right, what I would tend to do is use a letter to help you. I would use 5A for the 5 adult tickets, plus 3 children, 3C for the price of the children's tickets. Add that up, it gives you 158.25. That is all we need for 1 mark. Remember, look at how many marks the question's worth. It does give you an idea of how much working to expect. Okay. Next one. Now remember, A is an adult and C is the child price. Ben buys 3 adults, 2 children. Oh, that's not so good. Let's try that, see if that is a wee bit better. 2 children equals 98. There we go, there's our second equation. Okay, 1 mark. Now, without actually going on to part C, I'm pretty sure it's going to ask us to solve the equations, okay? This is simultaneous equations. Put one equation above the other and solve them. Now, let's see. I'm going to have to write this down on the next page. So 158.25, there we go, 3A, 2C, 98. Right. Calculate the cost of a ticket, right, okay. I've got the 2 equations written down, so to do this, I would suggest you write one equation above the other. 158.25. And the other equation was 3 adults and 2 children, was 98. Right, now when I'm doing simultaneous equations, if you would do this slightly different, you do your own, just double check the answer. The answer should be exactly the same, okay? Now when I do simultaneous equations, I would tend to try and get, generally I try to get these middle 2 terms up to the same number. But not only the same number, I would want one to be positive and one to be negative, okay? If that's not the method, again, do the way that you were shown. 3 and 2. 3 and 2 are both factors of the number 6. They go into 6, so I'm going to take them up to 6. How do I turn the first one into 6? Times it by 2. How do I get this 2 up to a 6? I'm going to times it by 3. But as I mentioned earlier, I like to get one to positive and one to negative, 6 and negative 6. So I'm going to multiply the bottom one by a negative 3. Okay? And this is going to give me 2 new equations. Right, now remember, multiplying by 2. Multiply the whole equation by 2, not just the 3C part. And this is a calculator question. 158.25. I'm going to multiply that by 2. 316.50. And I'm multiplying the second one by negative 3. Negative 9A. Take away 6C. 98 multiplied by 3, 294. Negative. Okay, and it's now at this point, because I have a positive and a negative 6C in the middle, we can add the 2 equations together, and if we add the equations together, positive 6, take away 6, they cancel out. So we've basically eliminated one of the letters. And now we have an equation that only has one letter. So we add up the equations. We always add up the equations if you have one positive and one negative. 10 add negative 9 is 10, take away 9. Really what we're left with is the letter A, one letter A. And 316, take away the 294. 316.50, take away that, gives us 22.5. Now before you go on, think of what A is, okay? We really shouldn't be leaving it as letter A equals 22.5. A was the price of an adult ticket. You must state it very, very clearly. And it's not 22.5, it's £22.50, okay? If you write 22.5, chances are you'll get a mark taken off. Now the question says find the cost of an adult and a child ticket. Okay, so we're not finished, we need to find out what the letter C stands for. once you've found one value, sub it in to your equation to get your other value. Choose the easy equation, right? If there's an equation that doesn't have a negative or lower numbers, maybe sub it into that one. I'm going to choose that equation there. So I've got 3a plus 2c is equal to 98. I already know what a is 2250. So that means 3 times 2250, add on 2c is equal to 98. Now when I do 3 times 2250, I get £67.50. So what I've got is £67.50, add on 2c is equal to 98. Now how do I find c? Well, I take 98, take away 67.50. Now if I do that subtraction, it would help if I get a wee bit extra space. 98 take away 67.50 is £30.50. Okay, I'm going to wipe out this wee bit here. Right, that's fine. So basically what I've got is 2c is equal to 30.5. So how do I find c? Divide 30.5 divided by 2. Gives you 15.25. Now again, don't leave your final answers, okay, with a equals and c equals. You must state very clearly an adult is £22.50 and a child is 15.25. Okay, that's our answers there. You must state it very, very clearly. Okay, please don't leave it as a equals and b equals. You will not get full marks. Right, okay, number 4. A runner has recorded her times for 6 different laps. Calculate the mean. Right, the mean is the average. To find the mean, you add up all the values in the list and divide it by how many values you've got. 53, add 57, add 58, add 60, add 55, add 56. Okay, we're going to add up all these values and divide by how many? 1, 2, 3, 4, 5, 6. Divide by 6, that was a wee 55 in there. Okay, and divide it by 6 because there's 6 numbers. Add them up. And you should be checking this on your calculator. Now, most times, not always, but most times, these tend to be a whole number answer, or maybe just something with a 1 decimal place. Now, when I divide this by 6, remember we're dividing it by 6 here, 56.5. Okay, that's the mean, part 1. 1 mark, that's all it is for that. Okay, part 2, hopefully you maybe recognise the question. It's a paper 2 question. It's a mean and standard deviation. Okay, calculate the standard deviation of these lap times. Now, to be able to do this, we actually need the lap times. So 53, 57, oops, 53, 57, 58, 60, 55 and 56. Okay. Right. So these numbers were, I'm just going to write them down again, 53, 57, these were the numbers in the original question. Okay, and we need the mean. Okay, the mean that we've just worked out is 56.5. Sometimes they actually ask you, find the mean and the standard deviation. It's the one question. They've broken it up a wee bit and they've said part 1, find the mean, part B or part 2, find the standard deviation. Right, watch how we do this now. Please, if you would have done it slightly different, do it your way, then double check you get the same answer. Okay? Right, so what I would do is I set up the values in a table with 3 columns. Okay, in the first column I am putting the numbers that were given in the original question. Okay. The middle column, I call the middle column, you don't really need a heading as such, but I like to think of the middle column as the D column. D as in the difference, okay? And it's the difference between each of the values that were given, the difference between each one and the mean. So, the mean is 56.5, the first number is 53. The difference between them is 3.5. One take away the other. Don't worry about one being positive, one being negative or anything like that. Don't worry, okay? The reason we don't need to worry about it here is because we're going to square all the numbers and make them all positive anyway. So the difference between 57 and 56.5 is 0.5. The difference between 58 and 56.5. Use your calculator, remember. Right? I'm not doing this with the calculator. The numbers are pretty straightforward, but remember it's a calculator paper. The difference between 60 and 56.5 is 3.5. The difference between 55 and 56.5, 1.5. Difference between the next one is 0.5. Okay, and as I mentioned, we're going to square them all. So I like to think of this column as the differences squared. D or D squared, okay? Square all these numbers. And again, use your calculator. 12.25. Okay, square the numbers. Don't assume that you know them. Okay, you may know some of them, but double check. Sometimes you get some repeated. That one's a 12.25, that's a 2.25, and a 0.25. Okay, this is a part here where sometimes we get some people getting a wee bit confused at where do we go now. Okay, we get the total. Okay, add them up. Let's see. Oops. Please double check everything that you hit in the calculator. Right, I total them up is 29.5. 29.5. Okay, now we're almost there, a couple of steps away. Now what we do is we divide this number by 1 less than how many values you have. N minus 1. We've got 6 values. We're not dividing by 6, we divide by 5. Okay, if you divide this number by 5, you get 5.9. That is not the standard deviation. The standard deviation is actually the square root of 5.9. Okay, square root of 5.9, and double check because sometimes it might mention about rounding. I'm going to leave it as 2.42. It doesn't mention anything about rounding. If you put 2.4, you're fine. Okay, the one after the 2 is an 8, so 2.43 is correct. Okay, 2.428 or 2.43. Okay. 2.43 or 2.4, it doesn't really matter what you leave it at. Again, it doesn't specify anything about rounding. Next part. Right, she changes her training routine, hoping to improve her consistency. After the change, she records her times for another 6 laps. So our means has changed and our standard deviation has changed. Has it proved the consistency? Right, the mean has our time changed, right? The mean is the time. When we're talking about the consistency in the numbers, we're actually talking about the standard deviation. So this question is actually asking about how has the standard deviation changed. Right, I'm going to have to go back and find, was it 2.43? Okay, so before the training, she changed to this new programme. So before the training, it was 2.4 or 2.4, something like that, 2.43. Now, it's telling us she's changed her programme. She's hoping to obviously do a bit better to improve how consistent she is. It's now 3.2. These are the standard deviations, okay? So this question is asking, has she improved consistency? Consistency is what we say is the standard deviation, gives us an idea about the consistency. So let's see. Basically, the lower the standard deviation, the better, right? The more consistent, the lower the standard deviation is. So now, she's actually got a higher standard deviation. That means she's actually less consistent. So although the mean might have improved, her times might have been improved, overall, her average time has improved, she has actually, in fact, overall, she's not as consistent. Okay, so maybe she's doing some really good laps, but she's also doing some maybe kind of slower laps. So the standard deviation has increased. And what that means is it's less consistent. Not as good. Not what she was hoping for. less consistent, okay? Or you could say our times are a lot more varied, if you want to put it that way. Next one, number 5. Okay, right, they're similar shapes. It's a similar shapes question. The small jar's got a height of this, the volume's this, the large jar has that height. What's the volume? Right, calculate the volume of the large jar. When I'm doing a similar shapes question, I always call one the new and one the old. The one that I know the information about, I call that the old one. The new one, the one that I'm trying to work out the value of, in this case, it's the volume of the large one. I'm going to call this the new shape. Okay, and I'm going to call that one the old shape. Now, any similar questions, similar figures questions we do is we work out the scale factor. Okay, and to find the scale factor, we do the new divided by the old. So, get a couple of matching up sides. We've got a couple of matching up sides. The height of the wee one is 15, and the height of the big one is 24. So, the scale factor is 24 over 15, and again you've got a calculator. 24 over 15 is 1.6. Basically that scale factor is telling you that the big one is 1.6 times bigger in height than the small one. Okay, now because it's 1.6 bigger in height compared to the small one, it doesn't actually mean it's only 1.6 times it in terms of volume. Okay, this is a volume scale factor question. So to get the volume, you actually need to cube that scale factor. This volume scale factor is 1.6 cubed. Okay, I don't know that wee extra, that's a 3 marks, that wee bit there. So it's 1.6 cubed. 1.6 cubed is 4.096. So to get the large volume then, it's actually the small volume times by 4.096. Times the small volume, which is 750, times it by 750, which gives you 3,072 cubic centimetres. Okay, some people do the scale factor or find the large volume by simply doing 1.6 cubed times 750. That's fine, as long as you get the same answer, it's not a bother. Next one is, here's certainly it's a triangle. It looks as if this is west, right? Okay. Lowtown is west of Midtown, right? West. And it says, is it directly north? Basically, they're asking you, is this a right angle triangle? That is what they're asking. It's a Pythagoras question. It's actually a converse of Pythagoras. They're asking you to prove or determine whether or not this is a right angled triangle. Basically do Pythagoras on it and see if it works. Okay, so let's have a go. If it is a right angled triangle there, because they're basically saying that one is north, okay, of that one, so it's 90 degrees, north, east, west, so there we are. Let's just check, is 85 squared add 75 squared? We're going to see if it's actually equal to 110 squared. Right, 85 squared, 7225. We're going to add on 75 squared, which is 5625. Add them together, gives you 12850. Right, that's what we get when we square and add the smaller two sides. If that number is 110 squared, it means it is a right angle triangle, because Pythagoras will actually work. Let's check. What is 110 squared? There's another way you can do this, and I'll just tell you in a wee minute. 110 squared is 12100. Those two numbers are not the same. Okay, so that means when we added 85 squared, add on 75 squared, it doesn't give us 110 squared. So what we need to say here, please, in your answer, it's by the converse of Pythagoras. Okay, we're basically using Pythagoras. The converse of Pythagoras, you must write that down. By the converse of Pythagoras, it is not north. Right? It's not a right angle triangle, first of all. It's not a right-angled triangle. That's what converse of Pythagoras is telling us. And because it's not a right-angled triangle, that means it's not north. Okay, now the reason we know it's not a right-angled triangle and therefore it's not north low, is not north high, it's because 85 squared add 75 squared does not equal 110 squared. Okay, so you must write your sentence about the converse of Pythagoras, whether it works, whether it doesn't. It proves whether it's right angled, it's not right angled, it's not north, and therefore that statement doesn't work. Okay. Right, next one, volume question. Remember, at the front of your exam booklet you will have a formula list. I think I've got a wee magic formula list about to appear round about now, hopefully. Oh, there we go. Right, number 7. It says hemisphere, copper, blah, 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 blah. Right, okay. Right, that's fine. Calculate the volume of the glass. Right, so we have a cone, and inside we've got a hemisphere. The hemisphere part is made of copper. The remaining part of the cone is the glass part that we're trying to work out. Right, whenever you see a shape like this, okay, you work out the volumes of the shapes you can see. So we're going to work out whether you work out the cone first, or it doesn't really make any difference. Right, the cone. There it's there, a third pi r squared h. Okay, which is a third times pi. Please make sure you read the information. The cone part, the cone, where is the cone? The cone has a diameter of 8. The radius for the formula, the radius is 4 then. Remember, the radius is half of the diameter. And the height of the cone is 15. Okay, we're not worrying about rounding right now. At the end, we need to round to 2 significant figures. But that's at the end, not just now. Please don't round off answers in the middle of the question. Let's see, a third, 1 divided by 3 on your calculator for a third, times by pi, times by 4 squared, that's the radius, and times by 15, the height of the cone, 251.3. I would tend to leave as many numbers after the point as I can. I'll leave it as 327. Now I'm going to work out the cone, the sphere, sorry. Remember, we have the volume of a sphere, not a hemisphere. Okay, we'll work out the volume of the sphere and half it. There's the sphere there. 4/3 pi r cubed. Remember, this works out a full sphere. We only have a hemisphere. So it's 4/3. 4 divided by 3 on your calculator. It tells us the radius. No, it doesn't. It tells us the diameter of the hemisphere. The diameter is 7.4. Half is 7.4. The radius is 3.7. So the formula, 4/3 times pi, 4 divided by 3 times pi, and times by 3.7 cubed. 212.175, we'll say. Okay, leave quite a few numbers after the point. Remember, this is a full sphere. I actually need half this number divided by 2. Okay, so it's 106.087. So that's our 2 volumes. The cone has the sphere inside it, so the remaining part of the cone is the glass part. It's a subtraction we need to do here. Okay, so the subtraction is 251.3, take away the 106.08 number. Okay, do the subtraction, and I get about 145. Remembering, we're going to round it soon. 145.23. The question did say round it to correct to 2 significant figures. Okay, 2 significant figures. I'm going to get rid of this formula just now. Okay. The number is 145.23. We want it to 2 significant figures. 1, 2. two significant figures, first two digits, but check the next one. Is it 5 or more? Yes, it's a number 5. So we're not going to leave it as 145. We're going to actually round up to 150. 150. Get your units correct as well. These are all in centimetres. It's a volume cubed. 150.